Since we're working on quadratic equation, we need to show you how imaginary number can be used in a quadratic formula. So we have 2x squared plus 3x plus 5, and 2x squared plus 3x plus 5 is not factorable. So we will use the quadratic formula to solve for our values of x. So a is equal to 2, b is equal to 3, and c is equal to 5. And using the quadratic formula, which I am assuming you already memorized, which is x equals negative b plus or minus b squared minus 4ac all over 2a, we will replace all our numbers in the formula. So we have negative 3 plus or minus 3 squared, which is 9. 4 times 2 times 5 is equal to 40. And it stays negative because there's no negative in your a or c. All over 2 times a, which is 4. To further simplify this equation, we have x equals negative 3 plus or minus the square root of negative 31 all over 4, because 9 minus 40 is negative 31. Now, without the imaginary number, we can write it out. We can write our answer as undefined. However, since we know that the square root of a negative number is simply an I, or you can replace it with an imaginary number, we will write it out as negative 3 plus or minus I square root of 31 all over 4. And once again, I have two answers. I split into two. One is negative 3 plus I square root of 31 over 4, and the other one is negative 3 minus I square root of 31 over 4. Now, if you are wondering why I did not simplify square root of 31, it's because there's no factors or two numbers that when you factor it out will give you a pair of number that you can take out of the radical. That's why square root of 31 is a prime number, so it stays inside. Now, to move forward with our imaginary number, there is such a thing as complex number. And complex number in standard forms are basically group of numbers with real part and imaginary part. So this is how we simplify or rewrite our complex number with a real part and imaginary part. So an example of complex numbers will be 5 plus 3i, negative 7 minus 8i, and 3 plus I square root of 5. And they are complex number because we have the real part, which is 7, and we have the imaginary part, which is negative 8. So this is a complex number together with number 1 and number 3. We have several operations involving complex number. We can add, we can subtract, we can minus, and we can also divide complex number. So it's similar to combining like terms when we're working on polynomials. So I have three sets of complex numbers here, and we're going to add and subtract each of them. So the first example, we have 2 plus 3i and 5 minus 8i as our set of complex number, and we're going to add them up. So adding up and subtracting complex number is similar to combining like terms. So you combine the real part and you combine the imaginary part. And that's what happened in our solution for number 1. So 2 and 5 are real part, and 3i and negative 8i is our imaginary part. Simplifying the real part, we have 7, and the imaginary part, we have negative 5i. Now, since we have two operations in the middle, we know that plus and minus becomes minus. So our final answer will be 7 minus 5i. And this is our complex number in standard form because we have the real part and the imaginary part. And for number 2, we are subtracting. Now, the rule in subtracting is pretty much the same as addition. However, since we have a negative here as our operation, what I usually do is distribute the negative sign inside the parentheses, so I'll end up with addition. So this one works because it eliminates the negative number and you end up with addition. And adding is always easier than subtracting. So here, negative 3 becomes positive 3, and negative 5i becomes positive 5i because we are subtracting, and we're changing our operation from subtraction to addition. Now we can combine like terms. We combine the real part for 7 and 3, and the imaginary part, which is 2i and 5i. Simplifying our complex number, the answer will be 10 plus 7i. And that's example number 2. And for example number 3, we have 3 plus square root of negative 25 plus 8 minus square root of negative 1. So unlike 1 and 2, the first two example, we have an imaginary problem in our equation. But this time, we are going to produce the imaginary number before we can combine them, because we can't combine these two together because they don't have the same basis. So we know that square root of negative 25 can be simplified into 5i, and square root of negative 1 is simply I. So now that you have your real part and imaginary part for both sets, we can combine like terms or simply perform the rule in adding complex number. So the real part first, we have 3 and 8, which is equal to 11, and 5i minus I, which is 4i. So that is the sum of the two complex numbers for number 3.